get started. Today we are, Grayson, you'll be fine, I think, if you just kind of listen along. Today we're going to continue solving systems of equations by graphing, but not necessarily graphing. So look at this. So what we're going to do is basically be checking if the ordered pair is a solution. So we actually kind of talked about this yesterday, but I want to show you non-examples. So I'm going to take this first one and I'm going to substitute the x and y. I would like it if y'all would do this with me, simply because this is something you can do with me. So we would do -2 times 3 plus -5. You've got to be careful with those integers. That's why I'm using parentheses around them. So when I go to solve this, this would be -6 plus -5, which would be -11. And it is -11. So in this case, it works out for us. So let's check the other. So this would be 2 times 3 minus 2 times -5 equals -4. So 6 plus 10, well, clearly does not equal -4. So this would be a no. This is not a solution. So the good thing is you can actually go to, I know, y'all are excited. And you can actually graph the equations, which hopefully you kind of caught on to yesterday, maybe. Oh, there. So -2x plus y equals -11. There's the first one. And then 2x minus 2y equals -4. So obviously the point that we were talking about was 3 -5, which would be like here. So it is a point on this line, which is why it worked for one of them, but not the other. So you can easily graph this point. So 3 -5, and you can see that it's on one of the lines, but not the other. The other thing you can do is actually zoom out and then zoom in to where they do intersect, and you can actually, if you put your finger there, you can see what the solution is. In this case, it's 13, 15, which is definitely not 3 -5. Okay. So let's try another. Now we actually have it graphed. What we're going to do is grab our solution from the graph. We looked at this yesterday, but we'll do this again. So our point of intersection is here at 1, -3. Obviously, we would check our solution, but we're going to do that a couple other times with some others, so we'll just accept that this one is and move on. Save us a little bit of time since I've wasted time talking about pi. Okay. All right, I would like for you to check this one on your own, please. Let's see if it is a solution or not. It's going to trick you into believing that there is a solution. So this one is a no, because this second one doesn't work. All right, let's one more of these. And I guess I could have graphed it, but I'm going to save us that. Well, no. Now save us time. Let's check this last one here. Of course, we have x and y. So when I substitute, I have 4 equals 3 times 1 plus 1. So 4 equals 4. So that one works. When I do the second equation, we have 4 equals -1 plus 5. So 4 equals 4. So in this case, this one is a yes. So it's not always a no and it's not always a yes. Obviously, there can be mixed responses. So basically now you have two ways to figure out if an ordered pair is a solution or not, because you can graph it or you can use substitution, whichever you prefer. Questions? So your assignment is a little bit different. I'm trying to try some new things. Today is a maze. It is a Google slide. So you're going to be dragging and dropping arrows in order to show the direction of it. Y'all have done mazes before where you have to like shade it in. Instead of shading, you're going to be dragging and dropping the arrows where they belong. Trying to make things a little more interesting for you guys. Okay? All right, go ahead and get started. If you have questions, obviously I will be here.